Hello everyone, welcome to this video in our credit risk analysis series. Today we will be discussing exposure at default or EAD and how it's calculated using PySpark and a sample dataset. EAD is a critical measure in risk management, especially in banking and finance, as it helps estimate the potential loss in a lender faces if a borrower defaults. Using PySpark and Databricks, we will dive into a straightforward way to implement this calculation in a scalable environment. And purpose and explanations of the formula. The purpose of the EAD calculation is to estimate the total exposure in a lender might lose if a borrower defaults. The formula for EAD consider boost the current balance and the available credit adjusted by utilization factor UF. In our case, we set this factor at 0.7, representing the assumption that the borrower may utilize 70% of their unused credit limit by the time of default. And now we want to talk about functionalities of EAD in banking and finance credit risk assessment. EAD provides an estimated potential exposure if a borrower defaults, allowing banks to anticipate and manage the amount at risk and to set capital reserve accordingly. And we can mention some functionalities of EAD. First of all, loan pricing, then capital requirement, stress testing, and scenario analysis, and finally loan limit monitoring by understanding EAD. Okay, and now we focus on explanations of the formula. The EAD formula is as follows. EAD equal balance plus credit limit minus balance multiply utilization factor. Balance represents the current amount out by the borrower. Credit limit is the maximum allowable credit provided by the lender. Utilization factor, in this case 0.7 or 70%, estimate how much of the remaining credit might be drawn before default. In banking, EAD helps institutions approximate potential losses in a worst case scenario of default, making it an essential component of comprehensive credit analysis framework. Let's start the code. Import necessary modules from PySpark. And initialize Spark session. We start by importing Spark session and call from PySpark. The PySpark decision allows us to create a distributed environment for processing data, while column is used to reference column name in expression. And add a sample data set for created data. And now define a schema. And create a data frame. Here we define a sample dataset with the columns ID, balance, and credit limit. Each row represents a browse data with a unique ID, a current balance, and a credit limit. We then convert this dataset into a Spark data frame, making it easy to manipulate and perform operation and the data, like transformation and aggregations. And now I wanna write an expression for EAD. This line performs the EAD calculation using the formula we defined: balance plus credit minus balance multiply 0.7. Here we use with column to add a new column EAD to the data frame. Call balance represents the current balance out, and call here credit limit minus balance multiply 0.7 calculates the potential additional credit exposure, assuming that 70% of used credit limit could be drawn out happen before a default event. Okay, and finally we display the data frame with the calculated EAD values for each browser, providing a snapshot of each browser's exposure in the case of default. Okay, and you can see final result. In this video, we calculate the exposure at the default EAD for sample credit credit data using PySpark, helping us understanding the potential exposure risk if a borrower defaults. This measure combined with other probability of default give financial institutions insight to make informed decision on credit risk. Thank you for watching. If you find this tutorial useful, don't forget to like, share, and subscribe for more insight into credit risk analysis. Thank you. Bye.